Hello, everyone, and welcome back to Minic Analytics. I'm very pleased to have you back once again. In today's video, we're going to be talking about hyperparameter tuning. And before we get started, please consider subscribing to this channel. We are welcoming you to this wonderful community. Hit that notification bell so that you never miss any of our video updates. So with that said, let's get started. So what is hyperparameter tuning? Of course, by now, I assume you have dealt with several problems that relate to machine learning, and you have come across the term hyperparameters. So when we talk about hyperparameter tuning, this is the process of finding the optimal values for the hyperparameters of a machine learning model. Hyperparameters, so when we are talking about hyperparameters, so definitely these are parameters that do control the learning process of the model, such as the learning rate, the number of trees, for example, if you're using the random forest, or the regularization parameter in the logistic regression model. Hyperparameter tuning is an important process because definitely when we are trying to use the hyperparameter tuning, we're trying to improve the performance of the machine learning model. And by finding these optimal values for the hyperparameters, we're trying to ensure that the model is learning effectively and it's making accurate predictions. Of course, that is the goal when you're trying to build these machine learning models. You're trying to be at least accurate as possible when making these predictions. Okay, so why do we use hyperparameter tuning? So definitely there are many reasons as to why we use the hyperparameter tuning. So I'm just going to state a few that I've seen that are quite important. So one of the reasons as to why we use hyperparameter tuning is that we are trying to improve the model performance. So hyperparameter tuning can significantly improve the performance of a machine learning model. So it does this by finding the optimal values for the hyperparameters. And by doing this, we are going to ensure that the model is learning effectively and making accurate predictions. Making accurate predictions or being accurate by making these predictions is the major objective of building these models, because we are going to use these models to make predictions and we want to be as accurate as possible. So okay, so by tweaking these hyperparameters, we are trying to increase that accuracy score for our model. Okay, another reason as to why we use hyperparameter tuning is to reduce overfitting. Overfitting is when a machine learning model learns too much from the training data and starts to make poor predictions on the new data. So to try to reduce this overfitting, because when your model is overfitting, it is performing poorly in a new set of data. That means that when making those when it's making those predictions, when supplying in a new set of data, it performs really poorly. That means it learned a lot about your training set, but it did not generalize. Okay, so with hyperparameter tuning, we will be trying to reduce this. And also, lastly, is about model interpretability. So hyperparameter tuning can help make machine learning models more interpretable. It does this by understanding the effects of different hyperparameters on the model's performance. So different hyperparameters have different effects on the model. So maybe if you reduce n estimators, for example, in random forest, so n estimators will have a different effects than, let's say, what's another getting? Okay, for example, when we talk about the n estimators, so when you maybe use 50 or 100 or 200, definitely they will be having different effects on your machine learning model. So trying to tweak this with combination of other hyperparameters, you'll now find which combination works best for your model. Okay. There are different techniques or methods that you can use for this hyperparameter tuning, uh, such as the randomized SearchCV. We have the grid SearchCV, or you can use modules like Optuna or HyperOpt. I think I'm getting that correctly. So there are different techniques. So I'll be going through all those techniques that you can use while doing this hyperparameter tuning. So the first one for this video will be about the randomized search CV. So with the randomized search CV, this one uses random sampling to search for the optimal values of the hyperparameters. So you provide hyperparameters and it uses a random sampling so as to search for these optimal values for the hyperparameters. With the randomized search CV, it's almost similar to the grid search, but it is more efficient than the grid search because the grid search will try out all possible combination of the hyperparameter values, and when the search space is quite wide, then it might take time for the grid search to find the best combination of hyperparameters. So with the randomized search, what gives the randomized search an upper hand because it just it works by randomly sampling from the space of possible hyperparameters that you have supplied and evaluating the performance of the model on each set of hyperparameter values. So it just uses it randomly selects the different values and tries to evaluate the model performance based on those values to generate the best hyperparameter values. So the best set, so after doing this, the best set of hyperparameter values is then selected based on the model performance. So it's not going to try every combination. So it's just going to randomly search, then generate the best from that. So randomized search CV is a good choice for hyperparameter tuning when the search space is quite large and you want to find the optimal values for the hyperparameters efficiently. So that's why it's better than the grid search. So I think in terms of it, when you're doing that search, it will spend less time than the grid search. Okay, so this is what we are going to be doing for this. We are going to try out hyperparameter tuning using the randomized search. So we are now going to jump in and start the process of using the randomized search CV. So once again, before we get started, please consider subscribing, hit that notification bell, and without that said, let's get started. So as usual, we're going to start by importing the necessary libraries. So we're going to import the libraries. So I'll import pandas as a PD, then I will import numpy as NP. So we are not going to be doing a lot of visualization. So for that reason, I'm not going to import the libraries that are necessary for visualization. Okay. So just start. Then after this, I'm going to now move on to import the datasets. For the datasets. So for the dataset, so pd. So I'm using the read CSV function. So read CSV function. Then I'm supplying in the function. We are going to supply in this is the file path of the dataset and df dot head. So this will just print the first 5 pd pdf.head. Okay, so with the head method, we're just printing the first 5 rows of the data frame. And after this, data summary, just to get an overview of the data. So under data summary, you can see that we have a total of 2768 entries. So these are the number of rows in the data frame. We have a total of 10 columns. These are the columns: ID, pregnancies, glucose, blood pressure. So remember, this is a diabetes data set. In terms of the null count, we have the same number, the same value under the null column per se with the number of entries. So we are not missing any values. And you can see the different data types of the values in those columns. Another step that is quite important under data cleaning. So we are not missing values. So I won't go further into that, but I will check for duplicates. So checking for duplicates. So for the duplicates, I'll use the duplicated method. Duplicated. Then inside the brackets, keep this one to be false. And I'll just sum, get the total duplicated rows in the data frame. So we are getting 0, so we are missing, or our data frame does not contain duplicated rows. Moving on, so we can then move on to now import the necessary libraries for conducting the randomized, I think it's the randomized search hyperparameter tuning. So let's move on to import those libraries. So for this, I will be using the just import libraries. So here I'll be using the one of the algorithm that I will be using will be the gradient boosting classifier. So again, from scikit-learn ensemble, we're going to import gradient boosting classifier. So I don't want classifier, I think that's correct. So gradient boosting classifier. Another thing will be about the train test split. So again, from scikit-learn dot model selection, model with an underscore, the selection. Here we are going to import the train test split, train test split, make sure train test split. Okay, so train test splits. Also for cross validation steps, I'm going to use the stratified k-fold. So I'm going to import that. So stratified k-fold. Also I'll import the cross-val, because we are also dealing with the cross-validation. So I'll also import the cross-val score, cross-val predicts. For the metrics, so we are dealing with both the classification. So we'll see how we are going to apply the same for classification, and how we are going to apply the same for a regression example, or an example or a regression test. Okay, so for that, I'm going to import the necessary metrics that will be used for evaluation. So for classification, you can use the accuracy score, the classification report, the confusion matrix. Depends on what we will decide. For the regression, we will use for regression, I think we can use the mean, is it mean absolute error? So we can use the mean absolute error, the mean squared error, the R2 score. So those will be necessary for for, for regression analysis. So I'll also import the elephant in the room, that is the randomized search CV. I think randomized search cross validation, if I'm not wrong. The randomized search cross validation. That's the model that we will be using. This. So if you can just search the randomized search cross validation. If you just do a quick search, you can see that the randomized search on hyperparameter tuning, the randomized search CV implements a fit underscore method. It also implement the score sample, speed predict probad, decision function, other things. So if you want to learn more about the randomized search CV, you can just Google the randomized search CV. Then when you go to the scikit-learn, this is the website. Here you can able to learn a few things about the randomized search CV when it comes to hyperparameter tuning. Okay, so this is what we are using in this analysis. Okay, so randomized search. Okay, so I think we have imported the necessary libraries or the modules for this. Another thing that we can, or we have forgotten one, the standard scaler. The standard scaler is important because you can see that our data is in a varied scale. So we will use the standard scaler to try to squeeze that data into certain range, so that we don't have some attributes over or doing other attributes when it comes to our model. Okay? So after importing these libraries, we can then not imported the extra trees. So after importing these libraries, we can then go on to define. We are going to define the features and the target variable. So here, for the features, so those are the dependent, the independent, dependent, the dependent or the independent. Okay, let's just call them so X. So df dot drop. So basically, what we are doing, our input features will be these other columns. These are the columns. So there's some issue here. I will drop the first column ID. So I think that is irrelevant. So I'm going to drop this column ID. I think for our case, I think it won't be necessary. So we just go ahead and drop that. So when dropping this, I'm going to use the drop function. So this is a function from pandas. So we can drop these columns. So just before this, you can drop these columns. Let's say we're going to drop the column ID. Just copy this, then paste it here. We are going to drop the column ID from our data frame. So I've used the drop function. Okay. So earlier on, as I was saying, outcome is our the target variable. So I'm going to drop that column from our target, from our input features. So I'm going to drop that. So this one is easier, instead of providing a list of all the columns in your data frame. So columns, that's okay. So just that's it. So we are dropping the column, then the target variable column. Then for our target variable, here we can use, let's say, y. Then we can use, since we are dropping this from our features, we can then use it or specify that this is our target variable. Okay, so it's just simple as that. So by this, we have defined our features. Then after this, we do a train test split. So split the data into the training set and the testing set. As usual, we know the X train, X test, Y train. So that's what we are going to be using here. So after defining our features, X and Y, then we are using the train test split function to split our data into the training set that will be used to train our model and the X test that will be used to validate our model. Okay. So this is about the train test split. Then after this, we can now use the standard scalar. I'll start by initialize the scalar. So initialize the scalar, or you can say just creating an object of the standard scalar. So scalar in standard scalar. Okay. Then after this, you can then move forward to fit and transform the training sets. So here we are, X train scaled. So here we recall the scalar. So here we fit and transform. So fits and transform. We are fitting and transforming our training sets. This training set. This is what we are fitting and transforming. And after this, we transform the testing set. But remember, the testing set, this we are the X test. That will be the X test. Okay. So we are just using the same scalar to transform the X test data. Okay. Then after this, so we can let's see how we can perform. We can use the gradient boosting classifier on our testing data to see its performance. Okay. So generally, before performing hyperparameter tuning, you must have used your training data, and you must have used your classifier or the algorithm that you have selected. You must have used that on your training data and to see how the algorithm is performing. Then if it's performing below the expectation, then you perform the hyperparameter tuning. So let's see how we can apply we can train a model using the gradient boosting classifier. So training a model using the classifier. So here, remember, we are using the gradient boosting classifier. So I'll just create a function that will enable us to perform build a model, a gradient boosting classifier. So def objective. So I'm specifying the name of the function. So objective. Then you can say X train scale, and the Y train. Okay. So this is the function. So then I will create an instance of the gradient boosting classifier. So create an instance of the gradient boosting. So I like using these comments because they can, so by just reading through my code, you can determine or see what I'm specifically doing. So we can create that instance of the gradient boosting classifier. So after creating this, and then the reason as to why I imported the cross validation. So that's what I'm going to be using now. So I'm going to use the the validation. The cross validation. So CV. So CV. Then you can use a stratified default. ST stratified k-fold. Inside the brackets, we say n splits and say these are 5. Then we are going to shuffle true. Then random states. Then there's no need of using the random states. Then after this, we are going to use the cross validation to get predictions using the cross validation. So after this, we are going to use the cross val predict to get predictions using the cross validation that we created earlier. Let me just space. After this, I think this don't need this one. Okay. So after this, we can then print the classification report. So we can then move on and print the classification report. So from the classification report, we can see how our model is performing. Then from here, we can just call the function. So we call the objective function. So say objective. Here we can say x10 scale, y10. So basically this. We're just calling this function. So when we execute this cell, what we are going to get is the classification report of the gradient boosting classifier on our training data. So this is how, so if we were to build a model that will predict diabetes based on the input features that we provided, this is how our model will perform. Okay? So generally, we are getting precision for class 0 and class 1, 9.89 and 0.86. So generally, we are getting good scores for the precision, for the recall. And if you're getting better scores for this, then definitely our F1 score will be quite be a good score. And also getting an accuracy of about 0.88, that is about 88%. Generally, our model is performing well. Cannot say it's worst off. But so now I think you have seen how we can build a model using the gradient boosting classifier. So after building our model, now this is when you can now apply your randomized search cross validator. So this will help you now to do a hyperparameter tuning so that you select the best hyperparameters for your model. Okay, so by that by selecting the best hyperparameters, then we seek to improve our precision, our recall, as well as the accuracy of the model. So let's see how we are going to apply the randomized SearchCV for hyperparameter tuning. Okay, so we can just say applying the randomized search CV. Okay. Let's see how we can apply this for hyperparameter tuning. Okay. Okay, applying the randomized search CV. Okay. Lowercase. So applying the randomized search CV. So here we start by defining the gradient, or creating an instance of the gradient boosting classifier. So yet we create an instance of the gradient boosting classifier. Classifier. Okay, so that's it. So I can just say db classifier. Just say CLF classifier. Then we recall the gradient boosting. Basically, we're just creating this here. Just say random states. Don't need it moment. After we have defined the instance of the gradient boosting classifier, we can then move on and define the hyperparameter grid for the random search. So go on and let's go on and define. So this is basically what we are doing. We are trying to create a search space. Okay, so we are going to define the hyperparameter grid, the random. So this grid is like a search space that our randomized search will be looking inside that space to get the best combination of the hyperparameters. Okay, so yeah, again we are going to, for this grid, we are going to create it in a form of a dictionary. So we can say param dist, then we can create a grid for that. So in estimators, this we can say 20, 50, 100. So under the gradient search classifier, so when you do a shift tab, you'll get the hyperparameters. So these are by default, these are our hyperparameters. So we are trying to insert new values for these hyperparameters, and we are using the randomized search so that it's able to disclose these new values, then try to generate the best combination of these hyperparameters. Okay, so for the learning rate, the learning rates here, we can say 0.01, say 0.1, also say 0.01, let's say 0.01, okay. Also say 0.1, 0.01, let's say 0.1. I think that's it. Learning rate. Okay, so for the learning rate, okay, you can also add another one, which is the max depth. Also add let's say minimum sample split. Okay, the minimum sample split, as I said, these are the hyperparameters. Okay, so we're just picking randomly these hyperparameters and creating a dictionary of values for them, so that we can search the best combination. We can also add another one. Maybe we add minimum sample leave, the subsample. So this. So definitely, if you can add more parameters here. So if you want to try others, you can just add them here. Then after this, we create a randomized search CV object, or an instance for the randomized search. So create instance of the randomized search. Okay, so the random, so they say random search. You can say randomized search CV. So we just recall this randomized search CV. Then just paste it here. Then we set the brackets for this function. One of the arguments will be the gradient boosting classifier, so the instance for that. So after this, we can for the param distributions. So for this, basically this will be the param, this one, the dictionary that contains the parameters, their respective values. Then for scoring, this one we can use, let's use F1 score. We can say F1 macro, then that was for scoring. For how many cross validation steps, so CV, we say let's use 3. Then say a random state, this one we can say let's use 42. Then after this, you can then fit the random search to the training data. So here we're going to fit the random search to the data. So random search fit. So we're going to fit that to our training data. So xtrain scaled ytrain. Okay. Then after this, we can then get the best model for the random search. So get the best model in the random search. So here you can say, let's say best GB model. So here we can then say random search dot best estimator. Okay, we are moving on well. Then after this, we can then make predictions on the training data. So here we can say make predictions. So for the predictions, so we are going to print the classification report for the gradient boosting classifier. Okay, so after this, we can then print the classification report itself. So classification report. Then for this, it will be our y test, y spread. Okay. There's something that we're missing here. I think that is after getting the best model, you can then make predictions on the training data. So there's something that I'm miscalculating. So making predictions, you can say y spread on the training data. You can say the best GB model. This dot predict. We are going to predict this on the X test. supposed to be x-state scaled. And after making predictions, we can then print the classification report. So here we print the classification report of the best model. Okay. Then we can okay. So the last thing here will be we can then print the best hyperparameters that we found during the random search. So basically, this is the code that we are going to be executing. So as we started with creating an instance of the gradient boosting classifier. I think the spelling is correct, gradient boosting classifier. Then after this, we create our parameter distribution. This, as you saw, this is just a search space. So basically we're defining our search space where the randomized search CV will be searching for the best values for our hyperparameters. Then after that, we created an instance of the randomized search CV. So by this, it's taking our classifier, the parameter distribution, the type of scoring that we want, the cross validation, as well as the random states. Okay? Then after this, we fit our model to we fit the random search to our training data. So after finding the best, hyperparameters and their respective values, we fit that to our training data. So after running this, we then get the best model for the random search. So by this we get the best estimators for that. Then after we have discovered that, we can then make predictions. Maybe this we can just run this. So after this, oops, we are getting some error. Supposed to be 50. Let's execute this. So after we are done with that, we can then make predictions on our testing data to see how the model is performing. Then after that, we can print the classification report for that. Ypred supposed to be y, or we can just say ypred. So after making those predictions, we can then print the classification report to see how our model is performing, and we can then print the best type of parameters that were discovered, that were found. Okay, so when you execute this cell, you can see this is the classification report according to the gradient boosting. You can see this is the classification report, the best gradient boosting classifier. We have the precision recall and the F1 score. You can see we have our accuracy and the best. Also, we are getting the best hyperparameters for that. You can see sample rate and estimators, minimum sample speeds, minimum sample leaf, maximum depth, as well as the learning rate. Okay, so definitely, as you can see, run from the start. Let's see. Let's run this from the start and see. We are executing this from the beginning. So when you execute this, so basically, I think you have now seen how we can use the randomized search CV for hyperparameter tuning. So we have applied that, and these are the results that we are getting from that. As you can see, definitely we are getting lower score as what we were getting earlier. But definitely, this is I'm just showing you how you can apply a similar. You can use the randomized search for hyperparameter tuning. Okay, so this is how we can apply that. For example, using the gradient boosting classifier, we can do the same. But let's try this on the k nearest neighbors. So let's try this k nearest neighbors. So this is also another algorithm that we can use. So similar to what we did earlier. So it will just we are just be going to be repeating the same thing. So the first thing under this will be about we define the k nearest neighbor model. So we create an instance for that. Then after that, we create a parameter param distribution. This is the search space for that. So the k nearest k neighbors classifier. Again, it's very easy. We can just find the hyperparameters for the classifier. So just under this function, you can just use the shift tab, and it will generate the hyperparameters. Then after this, we create a randomized search object. So we create that. So let's create a randomized search CV object. This one is again we supply these features. The number, the KNN model. So this is our classifier. Then the param distribution. Again, this is the param distributions. Then this type of scoring, we are using the F1 macro. Cross validation 3. Number of iteration. So again, it will 10 times. Jobs, I think this one is relevant as now. Then the random set 42. So after we are done with that, we can then move on to the next step, which is fit the random search to the data. So we are going to fit this to our data. So we are fitting that to our X10 scale data. So after fitting that, we can then get the best model from the random search. So after fitting this, we now determine the best model with the appropriate hyperparameters. So we can then execute this. K near neighbors classifier is not defined. So we did not import the k neighbors classifier. So we can just let's say here create a new cell, then import our classifier, then we can execute that. Then after this, we can then make predictions So we make predictions on our testing data, then print the classification report for the best model, as well as the best hyperparameters for that model. Okay. So when you execute this, so this is what we are getting from that. Let's see for the almost getting perfect scores for this. So this is how you can apply now the randomized search CV for hyperparameter tuning. So we have used that on the gradient boosting, and I'll also use that for the k neighbors. Okay. So for the k neighbors, these are the best type of parameters. So weights will be distance. P should be 2, the neighbors should be 2, algorithm should be the KD tree. Okay. So basically that's how you can apply that. So here we were applying the randomized search CV for classification. So we are going to move, now we are going to apply the randomized search CV for if you are for a regression problem. Okay. So this one is now for regression. So for regression, I won't be using the same data that we are using. This one was for a classification data. So I'm going to import a new data for a regression that will need us to use a regression algorithm. So I'm going to import that. So I'm going to import the data set. So this is a car price prediction data. I'm going to execute this. So this is the data. Again, I'll perform some summary data. For data summary, again, You can see our range index. We don't have missing values. You can see the different data types for the values in our in the column attributes. So for this, I'm going to drop these columns, the unnamed column, as well as the mileage unit columns. I'm going to drop those columns from the data frame. Okay. Then when I execute this, you can see that we have dropped those columns. Then I will do some renaming of these columns that we fully understand, provide better description for the attributes. Okay. So when renaming the columns, I use the rename function, then just specify the columns and provided a dictionary for each value and what I intend to rename. Okay, so for example, name is the original name, the undercase letter. Then we just rename that to this. So it's just a slight change for that. Okay. For this data, you can see that we do have categorical values, and most of these algorithms they won't accept these categorical values as input. So we need to change that to numeric values. So we can use encoding. So I'm going to use the simplest encoder, and that is the label encoder. So encoding. So I'm going to import the label encoder. So from scikit-learn preprocessing, so import the label encoder, label encoder. Then after importing this label encoder, the next step, I'm going to create a list of the columns to encode. So create a list of the columns to encode. So I'm going to create a new variable, so columns. Just rename that columns. So df, I'm going to use the select dtypes function. So one way to create this list is to, for example, create a list, then you start inputting the columns or the attributes with the categorical values. Okay, so for example, name, fuel, sales type, okay, owner. So one way is to use this method. Example, this then seller, okay, seller type. So I think one way is to use you create a list and specify the specific attributes or the specific columns. Okay, but in some cases you will be dealing with a large data set that has many attributes, and by listing those creating a list of those attributes manually, it will be quite time consuming. So the shortcut for this is to just use the function select dtypes, which will select the dtypes according to what you have specified. Okay, so for example, I'm going to specify my so df dot select dtypes. So when selecting these data types, you'll only include. So before I complete that, so for example, if I say use the info method, when we use the info method under the data types, you can see we have object, either integers or floats. So those are the data types for the values in the respective columns. But since I'm encoding, I won't be necessarily using encoding columns that already have a numeric input. Okay, so those are either is an integer or a float. I'm only concerned with the columns that have object as a data type, okay, or a categorical value as as uh, the columns that already contain categorical values. So those are the columns that I'm really concerned with. So when creating this list, I'm going to create that list using the select columns that only the data types will be an object. Okay, so I'm going to specify object. So it will only sample all the columns that do have an object as the data type. Okay. So after this, I'm going to create a copy of the original data frame so that when doing the label encoding, we are not we are not giving any attention to the columns or the columns containing a numeric input. Okay. So after this, you can then initialize the label encoder and perform the label encoding. This is how I'm going to do it. I'm going to initialize the label encoder or create something like a list for that. Then use a for loop that is going to perform the label encoding. So inside the label encoder, I'm creating the label inside the loop. I'm creating an instance of the label encoder, then using the fit transform to perform the label encoding. Okay. So remember, after this, since we created a copy of the original data frame, we can then go back to what we were using as the data frame, and then print. So when I execute this, you can see that we have now provided numeric, we have substituted the categorical values with numeric values. So with these values, then I think we are set because our algorithm will now accept this as the input values. Then after this, we are going to define the features and the target variable, just as we did in the previous step. So for our features, first I'm going to drop any null values. Then after we drop those null values, then our features will be, for here, let's use xn. And for, okay, there's no problem. Let's just use x and y. So for the features, and these are the dependent features. The independent variable will be the price. So the price of the car is our independent variable, what we are trying to predict. And the features are the dependent variables. Okay. So after that, we move on to the train test split. So train test split. So X train, X test, Y train, Y test. So we split our data into the respective train test and the testing set. Then after this, we initialize the standard scaler. So, so after initializing our standard scaler, then as you can see, we are dealing with values that are in different scale. And when we just use these values, when we inject these values the way they are into our model or our algorithm, then some attributes will be given because of their scale. They will be given more preference than the other. So to prevent that, we use the standard scaler that we try to squeeze that values in between. They will be having a mean of standard deviation of 1 with a mean of 0. Something. So let's just say so standard scalar. Standard scalar. So with the standard scalar, this is how we calculate the standard scalar. So by standard scalar, we are trying to standardize features by removing the mean and scaling to a unit variance. So the standard scalar score for sample x is calculated as follows, where u is the mean of the training samples, u. So with the standard scalar, what we are trying to do is centering and scaling happen independently and on each feature by computing the relevant statistics on the sample in the training set. Mean and standard deviation, and then stored be used on later data using the transform. With the standard scaler, let's see what is a standard scaler. So standard scaler removes the mean and scales each feature variable to a unit variance. This operation is performed feature-wise in an independent way. The standard scaler can influence by outliers, blah, blah, blah. So basically, you can just, let's say, what's a standard scaler? What is the use of a standard scaler? So a standard scaler, it adjusts the data to have a standardized distribution, okay? Maybe this can give us what we are searching for. With the standard scaler, it adjusts the data. The standard scaler class provided by the scikit-learn applies the standardization on the input features variable, making sure they have a mean of approximately 0 and a standard deviation of approximately 1. So by doing this, it adjusts the data to have a standardized distribution, making it suitable for modeling and ensuring that no single feature disproportional influences the algorithm due to difference in scale. Okay? Basically, that's what we are doing when we are trying to apply the standard scale. Okay? So after applying our standard scaler, we are done with that. Then we can then move on to, earlier on we used the gradient boosting regressor. So let's now change. Earlier on we used the gradient boosting classifier, sorry. So let's now use the gradient boosting regressor and apply on this data so that we can able to predict car price. Okay. So as we did earlier, so we are going to define the param list. So define the hyperparameters to search. So this is what we have defined. Then after this, we initialize the gradient boosting regressor model. We initialize that. Initialize the gradient boosting regressor model. Then after this, we initialize the random search CV. So here again, we can then say random search, randomized search, say randomized search CV. Inside the brackets, specify say GB model, then param distributions. Param distributions, so we just provide this. So then scoring, here I will use because this is a regression, I'm going to use, let me use what is it? The mean absolute error. So I'm going to use the mean absolute error. So the scoring. Then for CV, let's say I use 3. Then number of iterations, let's say 10. Number of iterations, you can say 10. So after this, then supposed to be random search. That's okay. Then perform the hyperparameter after. So earlier on, after performing the random search, it then fits its training data. So random search, random search, random search dot fit is supposed to be extrain scaled. Then you can say y-train. Okay. After this, then we move on to get the best parameters. So best params, just call that so random search dot best params. And after we are done with that, we can then, let's say, print the best hyperparameters. For this, we can print the best hyperparameter. So for the hyperparameters, we can say print the best hyperparameters. For the best hyperparameters, so yeah, I'm just going to create a for loop. So for key value best params dot items supposed to be here. Items, so print, I'll just use an f string. So f that, and then you can say the key. These are just placeholders. Then we say the value, the key and the value itself. Okay, come okay, print f key, then the value. Okay, so we can execute this or define the hyperparameters to search. This is what we have defined. Then initialize the gradient boosting regressor, initialize the random search, get the training data, get the best hyperparameters, then print them. This one is okay. We can execute this. So gradient boosting regressor is not defined. So okay, we did not import the gradient boosting regressor. So we can just, before we start hyperparameter tuning, we can then import the gradient boosting regressor. So we missed this, the gradient boosting. So we missed this. So again, from scikit-learn dot ensemble, so we're going to import gradient boosting regressor. Gradient boosting, I think it's okay. Regressor, gradient boosting regressor. I think that's one. Okay. You can execute this. Import the gradient boosting regressor. The mean absolute error. So you can also, we are dealing with the mean absolute error, so we can import that as our evaluation metric. So we can then say from scikit-learn dot metrics import mean absolute error. So we can also import the add to score. I think that's it. So from scikit-learn.metrics import mean absolute error, the error to score. I think we'll use those as our evaluation metric. So then we can execute this cell to import this. Then we can execute this so that we get to print the best hyperparameters. So after we have printed our best hyperparameters, we can then use these hyperparameters now. This one was too fast. Let's try to increase, let's say 5. The number of iterations, let's say 25. Okay. So I think the more you increase that, the more accurate the hyperparameters you will get. So from here, we can then make predictions on the testing data, make predictions from the testing data. So from here, we can say the best GB model equals to a random search dot best estimator, and from that we do a YPred. So with the YPred, we're going to predict the XTest data. So best GB model, YPred missing, supposed to be like this. So best GB model dot predict. This one is the XTest scaled. Boom, boom, boom. YPred GB model predict XTest scaled. Then after this, we can then evaluate the model, the testing data, Okay. So we are using the mean absolute error. So we can just say, so mean absolute error. So inside the brackets, y tests, then YPred. So the predictions against the ground truth, or what is considered to be the true value. So here we are basically making we're trying to evaluate our model using the y test, which is the true value, and what was predicted by our model. Okay. Then after this, we can then print the mean absolute error. Okay. We can print that. Then we can say, okay, when you execute this, you can see that the mean absolute error is about 47,777.93. Okay. So here, let's try to improve this to, let's say 50. So basically, this is how we can now apply the randomized search for given a regression problem. We just used the gradient boosting regressor. We imported our data. Then from there, we moved on to, since our data contained categorical values, we encoded those, substituted that with the numeric values. Then after that, we did we defined our features on the target variable, train test fit, then applied the standard scalar. Then from there, we imported the boosting regressor and the metrics that we are going to be using for evaluation. Then after that, we define the hyperparameter search for the with respect to the model. Then initialize that. Then initialize the random search CV, provided that with the features. Then we fitted the training data. Then we got the best hyperparameters. We printed them out. Then we used our model with the new hyperparameters to do a search. And if you're getting, let's just go back. That one was more accurate than the 50. When we execute this, we get the value of our mean absolute error. Okay. So for example, if you want to use the R2 score instead of the mean absolute error, so what can you do about that? So I think everything will remain the same. I'm just going to copy this and paste it. So here we can say using R2 score as the as the evaluation metric. So here I think everything will just remain the same. So I'm just going to copy that and paste. So as so this one this is the result for that. Mean absolute error, this value. Okay, so we have seen how we can apply the random search CV and obtain your and evaluate your model according to that. So here we are looking if you are going to use the R2 score. So the R squared score, we are not going to change a lot of things. Everything will just remain the same. So I've just copied and pasted it here. So for the scoring, what we are going to change when using the R squared is the scoring ways, or the scoring way. So here, instead of the mean absolute error, we're going to change that to R squared, like that. Everything just remains the same. So we can execute this and then copy this again, Control C and Control V. After we are done with this, so instead of the mean absolute error, again, remember we're using the R squared. We can just change a little bit some things here. So R2, say, then here we can say R2 score. We're still doing that on the Y test and the Y print. Then when printing this, just print the R2. But everything just remains the same. So it's not different. When you execute this, you just give it time for it to run. These are the best hyperparameters. This is the supposed to be R2. The R squared score. Just run this. So the R squared score when doing the hyperparameter search will be 0.9. Okay. So I think that's it for today. So basically, you have now, I think by now you have a full understanding of how you can apply the randomized search CV for hyperparameter tuning. So we have used that, we have applied that for a classification problem. We've also applied that for a regression problem. And you have seen how we can apply can apply that for hyperparameter tuning. So this was just for the gradient boosting regressor. So if you, let's say, get another algorithm, let's say the random forest, I think the sequences of or the steps that you are going to take will still remain the same, but some few things will change. For example, because different algorithms use different hyperparameters. So basically, some things that will change will be the parameter distribution. Okay, yeah, if you're using the random forest, it will change. This will change. But the random search, so inside the randomized search, so definitely some values will change, but the steps, I think I've tried my best to be all or inclusive, be all to be general in such a way that the steps for doing the randomized search will remain the same, but we just tweak a little bit of the details that you're providing. Overall, this is how you can apply this for the hyperparameter tuning. So I think this is all for today. This is all for my end. Once again, thank you for your time. And until next time, see you. Bye-bye.